Hello everyone, welcome back to Dr. K. Prem Primer video lecture series presenting by Dr. K. Prem, that's me. In today's lecture, we'll focus on adapters. When you want to clone any DNA fragment, compatible sticky ends are desirable. That means compatible sticky ends on DNA fragment to be cloned and compatible sticky ends on vector are necessary. When you have vector and insert with the compatible sticky ends, and they can be ligated, transformed, screened, and the recombinants are selected. If the DNA molecule, maybe genomic DNA fragments or cDNA molecule, if they don't possess the compatible sticky ends, then we can add those compatible sticky ends and we can clone. For that, there are three methods available to add the sticky ends to the DNA fragments. The first one is addition of linkers. The second one is the adapters. And third one is the homopolymer tailing. In the previous lecture, we talked about the how linkers can be added to the blended DNA molecules to generate the cohesive ends. In the today's lecture, we'll focus on the adapter molecules and their features and how we can use these adapters to add to the blended DNA molecule and how they are useful in the cloning. So here you can see this is a typical structure of a adapter molecule. In the next slide, we'll see some of the features of adapter molecule. Here, you can see that this is a typical structure of adapter molecule. Adapters are short synthetic oligonucleotides with free-formed cohesive end at one termini and blunt end at another termini. It means that they are these adapters are chemically synthesized, and one of the end is having cohesive ends. Other termini, there are two termini here. One termini have cohesive end, other termini have blunt end. You can see here, this is a one termini where you have EcoR1 cohesive end and other termini have blunt end. They're basically short synthetic oligonucleotides with two different ends, one at termini. One termini have cohesive ends, other termini have blunt ends. The second property is that blunt end of the adapter possess 5' phosphate and 3' OH like natural DNA participates in the formation of phosphodiester bond with the blunt ends of DNA molecule by DNA ligase. As I told you that the blunt end have 3' OH and 5' phosphate. One strand have 3' OH and other strand is having 5' phosphate. So like a natural DNA, right? So when you ligate adapter with the blunt end DNA fragments or inserts, so the blunt end, which is having the 3' OH and 5' phosphates involved in the phosphodiester bond formation, and that adapter binds to the or ligated to the DNA fragments. But cohesive end has 5' OH and 3' OH, which will not involve in the phosphodiester bond formation with the blended DNA nor with the another adapter by ligase. Here, the cohesive end have unnatural 5' hydroxyl group and natural 3' OH. As you all know that to form a phosphodiester bond, the 3' OH and 5' phosphates are necessary. If one of them is missing, especially 5' phosphate is missing, then that DNA molecule with the 5' OH or 3' OH cannot participate in the phosphodiesterone bond formation by DNA ligase. So here, one of the end that's having the coefficient is not going to involve in the phosphodiesterone bond formation and linking with the DNA fragment. So even it cannot link with the HO another linker also, right? So in the next slide, we'll see the how adapters are going to be generate the coefficients and involved in the gene cloning. You can see. As I told you, this is a typical structure of adapter with the blunt end have 3' OH and 5' phosphate, and the cohesive ends are having the 5' OH and 3' OH. The same thing is represented in a same way. So here, the adapters are desirable adapters with the restriction site or free-formed restriction site are selected, and blunted DNA fragments are also collected. Both are kept for ligation, and in ligation mixture, we add the T4 DNA ligase. So when you kept for ligation with the blunted DNA fragments and adapters, the blunt end of the adapter is going to be involved in the phosphodiesterone bond with the blunt ends of DNA fragments. After ligation, you can see that adapters are added at the both termini where blunt ends of the adapters are ligated with the blunt ends of the DNA fragments. Now you see the adapters with the DNA molecule have cohesive ends, but with the 5' OH and 3' OH. So the 5' OH, 3' OH are not compatible to form a phosphodiesterone bond with the vector molecule. Hence, it needs a modification. Means we need to make it a natural molecule by phosphorylating. For that, we need a polynucleotide kinase and ATP molecule. Adapters linked DNA molecules are subjected to the phosphorylation by PNK, that's a polynucleotide kinase, and when you supply the ATP, then 5' OH are phosphorylated. You can see 5' OH are phosphorylated. Now this molecule, the DNA fragment or insert, looks natural, like a natural DNA, where it have 3' OH and 5' phosphates. 3' OH and 5' phosphates. This molecule is now compatible to ligate with the vector. So vector also have cohesive ends, and the insert also have a cohesive ends. Here, the insert have EcoR1 cohesive ends, and the vector also have a EcoR1 cohesive ends. Then both vector and insert are ligated by using the T4 DNA ligase. Then the transformation mixture is transformed into the E. coli or other suitable host and screened for recombinants, and the recombinants will have recombinants will have a vector plus insert. This is a typical procedure to clone any DNA fragment with the blunt ends where we can add the adapters. Here you can see again it's the same thing procedure. Adapters with the desirable restriction sites are selected. Such adapters and blunt end DNA fragments or cDNA molecules are ligated using T4 DNA ligase. Adapters are ligated to both the termini of the DNA fragments. Then cohesive end OH of adapter ligate DNA are phosphorylated with a PNK, that's a polynucleotide kinase. And vector and DNA fragments are ligated by using T4 DNA ligase. Here you can, cohesive end ligation happen between the vector and insert. And finally, ligation mixture is transformed to screen and select the recombinant drugs. So this is what is the adapters. So finally I'm summarizing. Adapters have free-formed cohesive ends and blunt ends. The blunt end of the adapter binds to the uh, blunt end DNA molecule or insert molecule. Then the uh, cohesive end have pi prime OH that is phosphorylated with the PNK. Then it becomes a natural. With that, you can clone into the suitable vector. Thank you all for listening. This is all about adapters. If at all you like it, try to subscribe my channel. That's a Dr. K Prem Primer. And here, if you want to share, there is no issue. And here, if you like it, try to give thumbs up. And if you have any comments, let me know through the comment section. Thank you all.